Okay, the first thing I want you to notice is that we filled in these words here for the notes page for inequalities. So you use a closed dot for less than or equal to or greater than or equal to. So it's the equal to signs that cause you to use a closed dot. And then you use an open dot if it's just a less than or if it's just a greater than symbol. So the open dot means that the values are not included. So that's why there's no equal to sign. The closed dot means that the value is included, which is when we see an equal to sign. You also want to note in this section, the interval notation section, that parentheses are used in the same way that we would use an open dot, because it means that that particular number is not included. So recall that parentheses are just your slightly curved left and right side. So those are your open parentheses, which means that it's not included. Then we also have the bracket. So when we use the brackets, that means that the values are included. And recall that the brackets are the squared type of bracket, and that means that the value is included. And it's used in the same time that you would use a closed circle when you're graphing inequalities. So these next couple examples are just going to get us used to using interval notation. Example 1 shows us that we have 8 is greater than or equal to x. So since x is greater than or equal to 8, excuse me. So since we have 8 as a value, we're going to specify 8 on our number line. It doesn't really matter where we put it on the number line, as long as we can add a few extra numbers to make sure that we understand where it is. Now, we don't necessarily have to always write all the numbers, but we do have to have an 8. The fact that it's a greater than or equal to means that we're going to have a closed circle, because remember, whenever we have the equal to sign, we close the circle, and we're going to point the arrow in the direction of values that are greater than 8. And since 9, 10, 11, and so forth are greater than 8, we make the arrow go in that direction. Now, in interval notation, remember, we're going to identify whether 8 is in the solution set or it's not. And so since it is, we have that equal to sign, we're going to use the square bracket around the value for 8, saying that 8 is a boundary, but it's part of the solution set. And then we have to show the upper value. So we always do lower value on the left, upper value on the right. But this goes on to infinity. So we're going to use the infinity symbol. And the one thing that wasn't written above is that an infinity always has the curved bracket, so the parentheses. So we use the square bracket for the 8 to say 8 is included. And infinity, since we can never get to the end, we use that curved parenthesis to indicate that infinity is going on and on and on. Here in the second example, we have a is less than -1. So again, we're going to put a few numbers on our number line just so that we make sure that we understand where we are on the number line. And since -1 is the boundary to our value for a, we're going to put an open circle on -1. It's open because we do not have an equal to sign. There's no equal to sign there. It's just the less than. So we're just going to put the -1. And we're also going to note that the arrow is going to the left. It's pointing in the left-hand direction. A is less than -1. So we're going to put our arrow in the less than direction from -1. So it's going to face to the left. So now we have to look at our least value and our greatest value for our interval notation. So we have to note that our least value is actually in the negative infinity direction. So we're going to indicate negative infinity as our lowest value, but just like I mentioned before, infinity or negative infinity always carries the parenthesis or the curved bracket. And our upper value in this case is -1 because we've identified -1 as being the boundary. As we see here, we have the -1 as our boundary, but it's not included. Therefore, when we indicate in interval notation the boundary of -1, we're going to specify -1 here, but we're going to put the parenthesis or the curved bracket to say that it's not included, but it is the end of our solution set. All right, let's fill in the blanks to this middle section. When we solve inequalities, we use the same rules as we would solving an equation, but the one thing that we have to remember with inequalities is we have to reverse the inequality symbol if we multiply or divide by a negative number. So that's the only thing that's different when solving an inequality. We want to get the variable by itself. We want to get a number on the opposite side. We do distributive property. We combine like terms. We undo things from one side so that we can get it off of that side. We do all of those same things. The only difference is we reverse the inequality symbol whenever we multiply or divide by a negative number. So let's solve two of these real quickly, and then you should be able to do the rest of the sheet. Okay, so here we're going to solve number 3. So we need to get our variables on the same side. So currently we have a 5v on that side and a 7v on that side. So we need to get them on the same side. So I'm going to subtract 7v from each side so I have my variables together. So on the left side I end up with -2v plus 1 is greater than -17. So I need to move this +1 away because I want to isolate my variable over here. So I'm going to subtract 1 from both sides. And I end up with -2v is greater than -18. Okay, the last thing that I need to do is to divide by this -2 because currently it's multiplied by -2, the v is. But remember, we had that rule that when we divide by or multiply by a negative number, we have to reverse that inequality. So when I do that, I'm going to end up with, so that -2 divides out with the -2, we end up with v. Now I have to reverse that inequality is less than +9. So once I have my solution, now I can graph it. So I have this as my solution set just like we saw before. So it doesn't have an equal to sign, so that means I have an open circle. And since 9 is the boundary, I'm going to put it on my number line. And again, I don't have to write all these numbers on. I'm just doing it to make it obvious. So we're going to have an open circle at 9. And because it's less than, we're going to point in the less than direction, which is going to the left. So all of the values less than 9 are included in the set. So now we have to think about what's the lowest value that v can be. Well, if you recall, that would be -infinity because it goes all the way on. And remember, infinity always uses the curved bracket or the parenthesis. And the upper value to my values of v, because my values of v can be all of these values, but it stops at 9. So 9 is my boundary. So I'm going to put my boundary in there, and since 9 is not included, as we've noted already, it doesn't have the equal to sign, which is why we put the open circle, and it's the reason why we have to put the parenthesis or curved bracket. Okay, so let's just do number 4 here. So we're going to solve this equation first, or inequality first, and then we'll graph it. So we want to recognize that whenever we're solving an inequality, it's the same thing as solving an equation. So when we look at it, everything's over here on the left-hand side. All the variables are there. So we don't have to concentrate on the right-hand side at all. We're going to first simplify this side. And the first thing that we would simplify is this multiplication here. So we're going to distribute that -3, but I want to remember to put the 21x. So I'm going to write that down. So then we're going to distribute this -3 to the 5x and then the -3 to the 9. So we'll have -15x minus 27 is greater than or equal to 7. So we have everything written down. So now we can combine like terms. We have a 21x and we have a negative 15x. So we're going to combine those and we end up with 6x minus 27 is greater than or equal to 7. Okay, so now that both sides are simplified, we need to get our x by itself, so we have to get rid of all the extra things. So here's our x term, but we also have this extra term, so we're going to get rid of it by adding 27 to both sides. So when we add 27 to both sides, we end up with 6x is greater than or equal to 34. Okay, so now we need to get x by itself, and to do that we have to divide by 6 on both sides. So we have x is greater than or equal to 34 divided by 6 can be simplified because 2 goes into 34 and it also goes into 6. So 34 divided by 2 is 17. 6 divided by 2 is 3. So we have x is greater than or equal to 17/3. Now that seems like it's kind of hard to put on a number line, but it's actually not, because this improper fraction can be changed to a mixed number. So the denominator 3 goes into the numerator 17 exactly 5 times, so 5 with 2 left over. So 5 2/3. Okay, so now that we know that it's 5 2/3, we know that it's greater than 5 but less than 6. So I'm going to put 5 here on my number line, and I need to count over by thirds. So when I do that, I have 5 here, 1/3, 2/3, and then this makes the next number, which would be 6. So I'm going to put 6 there. So now to graph 5 2/3, we're simply just going to go from 5 to 1/3, 2/3, and this is where we're going to put our circle. So it's a closed circle since we have the equal to sign. So we have a closed circle at 5 2/3, and we're going to point the arrow to the right hand side because x is greater than that value. So we're going to point it in that direction. And so now when we write our interval notation, remember we're going to, because this is a closed circle, we have to use the square bracket. So we're going to use the square bracket for our value of 5 2/3, and we can use the 17/3 if we want to make it a little shorter. And then our right value, our greatest value, is going to be infinity because it goes on forever and ever. Remember, infinity takes the curved bracket or the parenthesis. So here's what we have so far. We've completed problems 1, 2, 3, and 4, and I'm going to go ahead and complete 5 and 6 off the video, and then I'll bring the video back up and show you those answers, and then you can finish the back. So here's number 15 solved. Actually, that last one was number 5 solved, and here's number 6 solved. The one thing I want to point out to you here is that once you solve the whole thing, it ends up as 3 is greater than or equal to m, but when we graph it, I like to put the variable on the left-hand side, so you just have to do the mirror image of the original inequality. So m is less than or equal to 3. These two things say the exact same thing, but this helps me to determine very quickly which way the arrow is going to point on my inequality down here. Because notice the arrow has always pointed in the same direction as the inequality arrow points. All right, so there's the answer to that one, and now you can do the rest on your own.